Hi, and welcome to our video concerning congruent figures. Now, this is in Chapter 4 of your geometry book, and it is the first section, starts on page 72. And while you're getting your workbook out to page 72, let's take a look at what our geometry standards are here in the Common Core. They are to prove theorems about lines and angles, which is under the standard of congruency, and our objectives to compare and analyze triangles by their structures to determine and prove that they are congruent. By the end of this lesson, you should be able to recognize congruent figures and their corresponding parts and determine if two triangles are congruent by applying some theorems of congruency. If all that seems confusing at this point, hopefully it won't be when we finish. So let's begin. You need to be on page 72 of your workbook. There'll be things to fill in along the way. Probably the best idea for you to do is to pause the video occasionally to be able to catch up with what's written down and really think about what you're writing down. Don't just fill in the blanks. See what they actually mean. So here we go. Our first key concept from the vocabulary talks about what they're calling Theorem 4-1. And here's what this means. We've got two angles of one triangle congruent to two angles of another triangle. Then that means that the third angles are congruent. So here's what that means. So we have angle A is being marked as being congruent to angle D. That's what those little arcs mean, congruency. So everything that's marked with a single little arc is congruent to everything else that's marked with a single little arc. And so the converse of that would be anything that's not marked with a single arc is not congruent to anything marked with a single arc. That should be fairly plain to what we're talking about. And so therefore, the ones that are marked here with what's called a double arc, those are congruent to each other. And the third angle, well, at this point we don't know about the third angle, but we do after taking a look at this theorem. The theorem states that if you know what two of the angles are, and two of the angles are congruent to two of the angles in the other triangle, then you know by this theorem that the third angles are congruent to each other. That's what Theorem 4-1 is all about, and in particular, this theorem tells us some things about what we're trying to do. So congruent polygons now is the second part of this. Congruent polygons are polygons that have corresponding sides that are congruent and corresponding angles are congruent. So looking at this particular set of triangles, we got this triangle DEF, and we got this triangle here GHI, and this triangle looks like if it were flipped over that way, it would be the same triangle as that one. We can prove that it's actually this by looking here. We got a single hash mark here, so DE is congruent to HG, and GI is congruent to all the ones that have three hash marks, so it's congruent to FI, and then EF is congruent to IH, and all the angles are also marked off. So once we know those things, when we know that three angles are congruent to three angles in the other triangle, and three sides are congruent to three sides, we know that the two triangles are in fact congruent to each other. Now we often write these things down, but they don't necessarily mean anything in terms of applying it. So we got to make sure that we can apply the knowledge to what we're dealing with. So I left all of this on here because honestly this seems pretty cut and dried and obvious. So we've got angles A and angle Q are congruent. That's what that sign is. Angle A and angle Q are congruent. So if this triangle here were flipped this way, I guess 90 degrees, it would be the same triangle, or at least look to be the same triangle. And then angle B is with angle T. Angle C is then with angle J. The sides, now this is important. You have to make sure that you label the sides in the correct order in this case. So the first one was AB. So we got AB. And so then it has to be labeled to be congruent with QT, because they're in the same order. We can't call them TQ, even though it's the same line. The right way to do it is to say QT, and if we do it the right way, we won't have problems down the line. So then BC is the one that is congruent to TJ, and AC is congruent to QJ. All right, so now using the congruency, and this is something that we've done before. This is about the triangle angle sum theorem. That means that every triangle has 180 degrees inside of it. So what they're saying here is use the triangle angle sum theorem in the definition of congruent polygons to find the measure of angle x. So we know that the measure of angle x plus the measure of angle y plus the measure of angle z in these two triangles up here, we know that this triangle here, xyz, that it has 180 degrees inside of it. We also know that KLM has 180 degrees inside of it. So we can use that information, and here's how you use it. So you put in 180 degrees for that, and then here's one thing that maybe we don't know quite yet. It's this, is that angle Z that this vertex right here, Z, it's in the same spot in this triangle as M. This is what I mean when I say that the order does matter on these things. So Z is in the same spot as M, and so therefore we can conclude that M and Z are the same measure. So they give us M, M's 48, so that means that Z also has to be 48 because Z and M are in fact congruent to each other because corresponding angles of congruent triangles are congruent to themselves. So the measure of angles is 48, so then we do 67 plus 48. Solving this algebraically, 67 plus 48 is 115. So the measure of angle x plus 115 equals 180. You subtract 115 from both sides, and you find out that the measure of angle x is in fact 65 degrees. So moving on. We want to find some congruent triangles. Can we conclude that triangle ABC, so here's A, B, and C, can we conclude that ABC is congruent to CDE? I'm going to warn you, this is a trick, and I'm going to show you why it's a trick. Let's take a closer look at that shape and see what we can find out about this shape. So here's the shape a little closer up. What do we know? Well, we have a single arc here. Angle A is congruent to angle E. What else do we know? Well, we've got B and D are both 90-degree angles. They're marked as 90-degree angles, and 90-degree angles are congruent to all of the 90-degree angles, so B is congruent to D. What else do we know? Well, we happen to know, based on this theorem, Theorem 4.1, that if you know that two corresponding angles of two triangles are congruent, you know that the third angle is also congruent. So we know that angle BCA is congruent to angle DCE. The order is very important for this problem in particular, but in general in geometry when you're doing these things. So remember that I labeled this, I put the 90-degree angle as the first angle in this particular angle. B, C, A, D, C, E in the same particular order. So what else do we know? Well, we know that congruent polygons are polygons that have corresponding sides that are congruent and corresponding angles that are congruent. So can we conclude that just yet? Let's have a look and see. We know that CA is congruent to CE because it's marked. We know that AB is congruent to ED because it is both marked as 3, and we know that BC is congruent to DC because it's also marked as being 4 units in length. So look what we have. We have 3 angles that are congruent, and we have 3 sides that are congruent. So based on this statement down here in this theorem, we can conclude that yes, this triangle here, the one on the left, is congruent to the one on the right. Now let's go back to the problem. I told you there was a little bit of a trick to it, and here's what it is, and I think it's a little bit of a dirty trick, but you know, that's how they test you to see if you're really paying attention to something. So ABC is the first triangle. So we have to start here, go to the right angle, and then go to the middle angle, if we want to call it the middle angle right here, where they can join together. Is that congruent to CDE? Maybe you've seen where I'm going with this. We start ABC and then CDE, they call it. So if ABC is congruent to CDE, then angle BAC here, would have to be congruent to DCE, and it's not, or at least we can't prove that it is one way or the other. So the diagram above shows that BAC, that's BAC, is congruent to DEC, not DCE. Seems like I'm saying a lot of initials, but that's just the way it goes. Anyway, the statement of ABC, triangle ABC, congruent to the triangle CDE is therefore not true. Now, please notice something here, that side BC, and we already talked about this, is congruent to CD or DC, and BA is congruent to DE, AC is congruent to EC. We just talked about all this business here, so therefore angle CBA is congruent to CDE, and angle BAC is congruent to DEC, so therefore using Theorem 4.1 we can conclude that angle ECD is congruent to ACB. And since all the corresponding sides and angles are congruent, the triangles are also congruent, so the correct way to state that would be the triangle ABC is congruent to triangle EDC, which is very, very similar to CDE, but the letters are not in the same order, and so we need to have the corresponding angles listed in the order that they're at. So I guess that's the whole point of that entire problem. Would you please, at this point, go do the quick check at the bottom of page 73 to show that you know what you're talking about. Look back, see what's going on, pause this video, and then when you get done with it, come on back and play it, and we'll go through those particular problems. And we're back. So triangle WYS congruent to triangle MKV. List the congruent corresponding parts. Use the 3 letters for each side. Well, so I've got W going with M and Y going with K and S going with V, so I have to put them in order. So here are 2 triangles. I'm going to label them this way, WYS and MKV. So my sides are going to be WY and MK. Another side, WS and MV. Third side, YS and KV. And the important thing here to note, you have to keep the letters in the correct order. So if I'm going top to bottom with MK, I need to do WY with that. So what about the angles? So the angles are going to be WSY and MVK, along with SWY and VMK, along with WYS and MKV. Let's go on. So it's given here that triangle WYS is congruent to triangle MKV. So if Y equals 35, what is M? I left this up there because this is really, really obvious. Y is the middle letter in the triangle. So K also being the middle letter. If Y is 35, then K is also 35. And the reason is that corresponding angles of congruent triangles are congruent and have the same measure. Now, can we conclude that triangle JKL is congruent to triangle MNL, and we need to justify our answer? So what do we know about this particular problem? Well, what I see here is I see that I've got J and M are both congruent. K and N are congruent. I also know that these 2 angles are congruent because they're vertical angles, so I know I've got 3 angles that are congruent. But look at the markings. The markings are a little off. This tells me that this, so KL is congruent to JL. I would need KL to be congruent to either LN or LM in order for us to be able to prove that it is. Now, even though it looks like it's congruent, we can't conclude that it's congruent because the markings don't tell us that it is. So therefore, we've got to say that no, the corresponding sides are not necessarily equal. All right, we're back into our work now. And I kind of want to move quickly through this because this is a proof, and we're not going to do a whole lot of proofs, but just to show you what this is all about. So I'm being asked to prove that CNG is congruent to DNG. So I got CNG and DNG. So it looks like they're still in order, so we're good to go there. So I've got CG is congruent to DG. That's given to us. They tell us that information up here. And then CN is congruent to DN. That's also given up there in our particular problem. And then GN is congruent to GN. Well, look, it's the same line. And so that is what's called the reflexive property of congruence. Reflexive because it's back on itself. So we know that the 3 sides are congruent. So what about angle C and angle D? Well, they are marked. They are given as being congruent, so we can say that. So look at all the things that we've already gotten. So we have to prove now that CNG is congruent to DNG. And they're saying here from the book that right angles are congruent, which is true. All right angles are congruent to all right angles. However, it's also given. So you can go either way on that one. So the last 2 things, so look what we've got. So we've got 1, 2, 3 sides that are congruent. We've got 2 angles that are congruent. So the only angles left to prove here are CGN and DGN. And we can do that by saying that the 2 angles of one triangle are congruent to 2 angles of another triangle, and the third angles are also congruent, and that's theorem 4-1. It's not important to know that it's called theorem 4-1, but there's a space, so we'll put a space in there, and that is actually the definition of congruent triangles. I'm going to ask you to stop at that point, even though there is a continuation part where we start talking a little bit about the quick check at the bottom of page 74 and all these different statements, but you don't need to do that for right now. But for what we needed to take care of, we took care of a lot of good information, got a lot of things down here, and here's how this actually works out if you do want to fill it in. But here's what we did with our objectives. We compared and analyzed triangles by their structures to determine and prove that they are congruent. We should be able to recognize congruent figures and their corresponding parts and determine if 2 triangles are congruent by applying theorems of congruency.